Hi everyone, I'm Fraser Cain. I'm the publisher of Universe Today. I've been a space and astronomy news journalist for over 20 years. Now this is the question show. Your questions, my answers. So wherever you are across my YouTube channel, if a question just pops in your brain, just write it down in any of the comments. I will gather them up and I will answer them here. Now normally I do this show live every Monday at 5 p.m. Pacific time. But for those of you who aren't aware, it's time for our summer hiatus. And so that means that we will be not doing any live streams through July and August. So the episode that you're watching right now is the last episode until we start up the new question shows again in the next season in September. And you'll get lots of announcements and stuff when it's about to happen. Now, we're still going to do other shows. We're going to be still doing the news segments every week. And we're going to be doing some other special stories. We'll probably do something on James Webb. We're working on an episode on Gaia, things like that. But no question shows and no interviews over the summer. So I hope you all have a fantastic summer. I know I will. And we will see all of you again in September. Now, last week, we had everybody vote for their favorite question, and the winner this week is Olerin, asking if this was possibly the dumbest question asked on the channel, they thought, but no, it was voted as a great question about moving Pluto into the orbit between Earth and Mars. So congratulations, Olerin. You've just got some validation that your question was terrific. Now, we won't do the voting this week because it's just going to take too long until next season. So again, have a great summer, and we'll see you in September. Now, let's get into the questions. Elementus. Could we use a hollow Starship as a large space telescope? What sort of resolution could we get from a telescope that size in space? So Starship has a 9-meter fairing. That is the width of the cavity inside Starship. And so theoretically, you could put a telescope that is 9 meters across. Now, that's not actually true, because even if you had a telescope mirror that was 9 meters across, you'd still need some spacecraft around it, and there'd still be some insulation on the inside of Starship. So maybe it would be 8 meters across would be like the biggest possible space telescope that you could fit inside Starship, but that's still bigger than James Webb. Now, I did some very rough math, and those astronomers out there, please don't beat me up. I just looked at the aperture of the telescope and used that to calculate the magnification. But as a baseline, the Hubble Space Telescope at 2.5 meters gives you a 6,000 times magnification, which is pretty amazing, and especially because it's out in space. You know, there's typically a limit to about 250 times magnification for an Earth-based telescope, thanks to the atmosphere. But once you're out in space, there's kind of no limit. James Webb at 6.5 meters gives you about 16,000 times magnification. So it's definitely almost triple the capability of Hubble. And so if you had a 9-meter telescope that you put inside Starship, you would get 22,500 magnification, which is about 3.75 times better than Hubble. So in other words, if you had a telescope that fit inside a Starship fairing and didn't require any folding, it was just a great big mirror, like an 8-meter mirror, which is kind of the size of some of the bigger telescope mirrors here on Earth. The Geminis, the Very Large Telescopes, the Vera Rubin, they're all in the 8-meter class telescope. You could fit one of these inside Starship. And what's kind of crazy about this is that you could have Starship be the telescope. It could fly to space. It could observe whatever targets the astronomers want to see. And then whenever it's time for an upgrade or whatever is needed, it can close the opening on its fairing. It can return to Earth, land. Astronomers can go and upgrade the various instruments on it, and then it can fly again and continue on. I think it would be an amazing idea to see a fully reusable 8-meter space telescope, which is just one of the things that theoretically Starship would be able to do. So yes, please. Kent Linkletter. Can James Webb see Hubble? I love this question. So last week, someone asked the question, can Hubble see James Webb? And the answer was yes. It'll just be able to see a pixel. And so then the question is, could James Webb see Hubble? And the answer is no, because James Webb is designed to always be looking away from the sun, the Earth, and the moon. Because of the orbit at the L2 point where it is, the Earth, the sun, and the moon are all clustered together in the same spot in the sky, and James Webb is protected by the sun shield. And so if it was to look in the direction of the Earth to try and see the Hubble Space Telescope, because Hubble is just in low Earth orbit around the Earth, it would also be looking at the sun, and it would be overheating, and it would be bad. Like, it could damage the telescope. At the very least, they would then have to spend another 6 months cooling the telescope down to get it into position again to be able to do these observations. And the crazy part is, with the Hubble Space Telescope, you can see it with your own eyes. Like, if you know where to look when it's going in orbit over your point of view on Earth, you can just watch it like a satellite fly overhead. It's just a dot, but people with fairly powerful telescopes are actually able to resolve the shape of the Hubble Space Telescope. And of course, you can do even better with the International Space Station. So no, James Webb couldn't see Hubble. Now, if Hubble wasn't beside the Earth, if Hubble was the same distance away, but it was away from the Earth, then sure, James Webb would be able to see it. It would look like, again, a dot. But because of where Hubble is located, it's actually tough to see. Peter Hopner. When the astronomers look at and talk about the big elliptical galaxies, they observe that star formation has stopped. Won't they eventually undergo gravitational collapse into disks and then the gas cool off so star formation can restart? No. The giant elliptical galaxies are pretty much dead. So how do you get a giant? So some of the biggest galaxies that we know of are these giant elliptical galaxies. And they are the result of many spiral galaxies like the Milky Way and Andromeda merging together. And so, like, the Milky Way is the result of dwarf galaxies coming together, and it's able to maintain that spiral shape. But when two big galaxies of roughly the same size merge, or even multiple ones, then all that spiral structure is lost, and you just get this big ball of stars. And all of the star-forming material, all of the cold gas that's available gets used up. You get this sort of period of extreme star formation, and then all of the reserves of gas are depleted, and the whole galaxy just starts to turn redder and redder and redder as all of the hot stars die, and you're just left with the long-lived cooler stars, the red dwarfs, etc. And the gas is used up. And so even if you go billions of years into the future, it's just going to turn redder and redder and redder. And essentially, they are fossils. They are relics of an earlier time. And that is the fate for the Milky Way when it merges with Andromeda. We'll have a few billion years of exciting star formation and interactions and tidal tails and stuff being spun out into space. But then the whole thing will just settle down to a big spherical blob and just cool down, and its star formation will cease. Mauricio Togneri. Hey Fraser, if future civilizations in the Milky Way won't be able to see other galaxies due to the expansion of the universe and therefore miss information and think that the universe works in a different way, could it be that we are also missing information, leading us to have a wrong picture of the universe? That's an interesting question. So the first part of what you talked about, this idea that future civilizations will lose this historical information. The universe is expanding. And when we get to some, point, the galaxy clusters will be accelerating away from us. It'll appear that they're going faster than the speed of light from our perspective. They will fall over the cosmic horizon, and they will redshift away out into the radio waves and effectively be invisible from our perspective. And so if you had some future civilization that arose in the universe, say 100 billion years from now, they wouldn't see any other galaxy clusters. They would just see the galaxies that were around them in orbit, the dwarf galaxies, and assume that that's the universe. But that's not true. That background radio waves, even though the wavelengths might be meters long, kilometers long, there will still be some information. And those future civilizations will be able to build their version of James Webb, which will be capable of observing highly redshifted galaxies and turning them into what they might look like today. And so if they were motivated and creative, they would eventually start to piece together the history of the universe. It's not gone. It's just very faint. But the question that you ask is like, is there something similar to us? Is there like is there some piece of information that existed in the universe and is now gone? And I mean, we don't think so, because when you look in a telescope, you're looking backwards in time. And so we look back in time and we see, even just a billion years after the Big Bang, we see galaxies, we see stars, we see things doing the same kinds of things then as we see them doing today. But the star formation is more active because the galaxies are more densely compacted together, and it's what you would expect. There's more just raw material in the universe, and so you get different effects, but we don't see something totally different. So because we can look backwards in time, we can observe those times that are long gone. And you think about other sciences like archaeology. Like, archaeologists would love to be able to look farther away and see backwards in time, to actually see people living in the Stone Age, or people living in, or watch dinosaurs walking around the earth, and they can't. But there's a great idea, if you read the Three Body Problem series, there's this idea, and I don't want to spoil it, that intelligent civilizations have had an impact on the environment of the universe at a very fundamental level. And so the universe that we see today is not how the universe looked at the beginning, that it is the net result of countless civilizations for their own purposes changing the very nature of the cosmos. And it's a really clever idea, and I highly recommend that you read the series, or I guess wait for the Netflix adaptation, and you'll get a sense of what I'm talking about. So probably not, but maybe, you never know. Landon Runseval. How will the Lunar Gateway change robotic space exploration? The Lunar Gateway is the new space station that NASA is building, and it's going to be placed in a lunar halo orbit. It's not going to be orbiting the moon, but it's going to be often coming close to the moon. And the purpose of the Gateway is that it's going to serve as a base of operations for astronauts to be able to come and go from the moon. So they'll launch in the Space Launch System. They'll fly to the Lunar Gateway in an Orion capsule. They'll get into a Starship, and they'll fly down to the surface of the moon. They'll collect some rocks, jump around. They'll get back in Starship. They'll fly back up to the Gateway, and then they will get back into their Orion capsule, and they'll fly back to the Earth. And once you've got that Lunar Gateway in place, then it makes future missions to the moon a lot easier to do. But your question was, how will it change robotic space exploration? And it's really designed for human space exploration. But that said, there's some really interesting ideas that are being tested through the idea of teleoperated robotics. So recently, one of the astronauts on board the International Space Station operated a rover in a test facility down here on Earth. But you can imagine the same thing happening on the moon. And so you can imagine future astronauts will be on the moon. Maybe they're out at the far side of the moon at various times, and yet they're able to be in a very close proximity to the rovers. They're able to have very short ping times to get to the rover, and they're able to run it like remote control. And, they might be wearing like a virtual reality headset, and they're going to be digging and building things and using arms. And so having humans very close to where your robotic spacecraft are doing their work is really helpful. I mean, we see, to be able to send commands to and from Mars, it's anywhere between, say, 4 and 20 minutes. And then return, you gotta wait for the return. But if you could be just milliseconds away from communicating with your rovers, either on Mars or on the moon, I think it'll change a lot. So I think that's where it will have an impact, is giving astronauts a platform to control robots remotely, safely, and yet very effectively. And we can see the same thing. A station on Phobos would do the same thing. You would have an astronaut up on Phobos. They would be controlling robots down the surface of Mars. It would be pretty cool. More questions in a second, but first I'd like to thank our patrons: Kami Racian, Anton Vesti, Jeff Gutierrez, Silent Phoenix, JB, Landon Runsval, Bo Danner, Una Martin Copy, and the rest of our 1,066 patrons for their generous support. Want our videos with no ads? Join our community at patreon.com/universetoday. And I'll also remove all the ads from the Universe Today website for life. Donovan Gustafson. Where are the ice giant Cassini-Huygens style orbiter landers? Are plutonium RTG difficulties to blame? In the most recent Planetary Science Decadal Survey, this is of course the wish list by scientists that they pull together every 10 years. in this version, they asked for an orbiter mission to go to Uranus. And so it will probably be something like Cassini or Galileo that will fly to Uranus, maybe Neptune, probably Uranus because it's quicker, and probably have a way of being able to examine one of its more interesting moons, like Miranda, and we'll be able to go into orbit for a long period of time. And it will definitely use an RTG. The RTGs are back in production, so there's no shortage of the nuclear batteries. There's going to be one given to the Titan Dragonfly. There's probably going to be others coming up. So really, it's just now time for it to be designed and constructed. But it's going to be a long time. Like, it probably won't be built until into the 2030s, probably 2030 it'll be launched, and probably won't get to Uranus until near the ends of the 2030s. It's just it takes so long to get out to the outer solar system. Just Keith, can you explain how artificial gravity spinning drums would work in space? If the astronauts are floating, how would a spinning drum add gravity? Rides on Earth require gravity. Yeah, if you had astronauts and they were floating in space, and then you had a giant rotating space station around them, and it was rotating, they would not be experiencing any kind of artificial gravity. But you can imagine, right? The station is going past them, and they reach out their hand, as the station is sliding past their hand, and then there's a handle, and they grab onto that handle. Now they get pulled along with the station, and now they're going the same speed around and around that the station is. And that's causing them to get a centripetal force that's pushing them outward. And so now that they experience that force as artificial gravity. So the way that you would get anyone to experience artificial gravity is you just set whatever they're in, whatever they're attached to, rotating, and they would experience a force outward. And that's how artificial gravity would work in space. Rob M. Hey Fraser, do scientists have any estimate of how many gravitational lenses are useful available at any one time? How lucky are we to see one? Do they last a day, year, or a century? A gravitational lens is where you've got some foreground object, like a galaxy cluster or a star, that acts as a natural lens with its gravity to magnify something that is perfectly behind it. And so you could, for example, have a galaxy cluster and then a galaxy on the other side. And so the light comes from the galaxy. It goes past the galaxy cluster. It is focused like a telescope to us as the observer. And then we see a galaxy that we would not normally be able to see. And they're used for discovering exoplanets. So you have a star that's far away, and then you have a star that passes in front, and it lenses as it passes in front. And if that lensing star has planets associated with it, then we can detect those as the signal that lenses. Your question was like, do we know how many there are? And we don't. We never could, because they're popping up all the time. And so in some cases, like the ones that happen within the Milky Way, they only happen for a few hours. So you'll be watching the sky, it will distort as a lensing event is happening. You point your telescopes at it, you tell other people to point their telescopes at it. You've got maybe a few hours, maybe a couple of days, and then that's it. Now, some of the bigger ones, the galaxy cluster ones that are billions of light years away, they're effectively forever from our perspective. Like, we find those lenses and we just know they're there. And astronomers have been doing surveys for these gravitational lenses. And we reported on this fairly recently that astronomers found a whole bunch of new gravitational lenses, some complete lenses, they call these Einstein rings, some partial lenses. And so just the more of the universe that gets carefully observed, we will find more and more examples of these gravitational lenses. Only a small portion of the universe has actually been observed at very high levels of detail. Like, you might be surprised to know that the Hubble Space Telescope has only observed about 1% of the sky at its capability. So there's lots more out there, we just haven't found them yet. Andy Cod 77. What lies beyond space is what I want to know. There must be an edge or something, right? When we look out, and the farthest thing that we can see is the beginning of time, because the light has taken 13.8 billion years to reach us. And so we can't see any farther, because what we're seeing is the first moment that light was able to escape into the universe. If we could see light, like if light moved instantaneously, then we could see the entire real universe. It might be infinite, and we would just see forever, but it would be very bright. It'd because we would be seeing all the light in all directions from all the stars that exist in the entire infinite possible universe. But instead, we see a fraction of the universe, of the true universe, because light moves at the speed of light. And so we can only see to the point that light started moving. So there is no edge, there is just more universe. Nessie. Hey Fraser, glad to see you again. Do you think that we'll be able to definitely prove if there is or isn't life on planets observed by James Webb in the near future, like 2035? I don't think so. I don't think that we're going to have definitive proof of life on other planets that we've detected with telescopes for decades, maybe ever, hundreds of years, maybe. And that's because it's really, really tricky to confirm conclusively that you have detected life, this thing called a biosignature. Now, think about here in the solar system. Astronomers have detected what seemed like bacterial activity in the Viking experiments back in 1977. More recently, scientists detected the presence of methane in the atmosphere of Mars, which is the kind of chemical that shouldn't be present in the atmosphere of Mars. And yet, it actually can be because there is a way to get methane through volcanic activity. We learned about the potential discovery of phosphine on Venus, but then astronomers are still arguing about whether or not that's real. And Venus is right over there. We've had spacecraft at Venus observing it. When you think about what James Webb is being called upon to do, it's looking at planets that are dozens of light years, hundreds of light years away. It's going to be able to detect the presence, just the very subtle presence of interesting molecules like carbon dioxide or ozone or oxygen or methane or water vapor or things like that. And maybe if we're really lucky, more complicated things. But it's going to be inconclusive. And there's no way to really be conclusive about it unless you could actually go there and land and take a look around. So that's why this idea of searching for technosignatures of some kind of evidence of a technological civilization is actually probably going to be more fruitful than just searching for just generic, like bacterial life. Because if you do detect a signal from a technological civilization, it's unambiguous. You know for sure that a technological civilization is sending out this radio signal to you, or is building a Dyson sphere that's surrounding one of their stars, or is filling their atmosphere with chlorofluorocarbons. And determining conclusively if you have a biological signature is actually going to be really hard. Now, over time, we will build bigger and bigger and better telescopes. Maybe someday we'll have this solar gravitational lens where you've got a telescope that's using the sun's gravity as a lens, and we would get a megapixel image of an exoplanet orbiting around another star. And maybe in that we could see the presence of forests or bacterial slime across vast portions of the planet. But we're probably looking at 50 years before we can have a spacecraft like that actually in play. So I would definitely brace yourself for a slow unfolding disappointment that we're going to get any kind of conclusive evidence of life beyond Earth thanks to telescopes like James Webb. They're going to be building a case, and some astronomers will think that the case is made, and other astronomers will think that it's not, and that conversation will go on, and new instruments and new telescopes will be built, and it's going to take a long time. Which sucks, I know. I mean, I want to know if we're alone in the universe or not, but it's going to take so much time for us to figure this out. Mark McDougall, could you use the moon as a gravitational lens to look at the Earth from Mars? The gravitational lens works better the stronger the gravity is. And so we talked about using the sun as a gravitational lens. You'd have to go to like 500 astronomical units to be able to use the sun's gravity. If you wanted to use Jupiter, you would have to go thousands of times farther. And if you wanted to use the moon, it would be just millions. I don't know the exact number, but it would be worthless. You'd have to go so far away to be able to use the moon's gravity as a lens. So no, what you want is a nice black hole that's present in the solar system. You can use that as a gravitational lens. That's the perfect gravitational lens, is a black hole, a pet black hole. J-bits. hey, how can we use science to look back in time? Not travel back in time, just look back, for example, what the Earth was like a million years ago. Unfortunately, there's no way for us to be able to use our telescopes to be able to look back in time where the telescope is. Like the telescope is located on Earth. And so when the telescope looks around, it's essentially seeing the Earth in real time. It's seeing the moon 2 seconds ago. It's seeing the sun 8 minutes ago. It's seeing Alpha Centauri 4 years ago. And yeah, we could look at a galaxy that is a million light years away, and we would be seeing that galaxy as it existed a million years ago, but that's not here, and so that's not very useful. Now, the one idea that people bring up is like, what if you used a black hole? Because a black hole will allow light to go in orbit around it, and so you could imagine the light emanates off of the Earth, goes to a black hole that is 500,000 light years away. It goes around the black hole and shines back on the Earth, and you look at it with your telescope and you are able to see what was happening on Earth a million years ago. And theoretically, it's possible in that there might be a photon that has made that journey, one photon, but practically it's impossible. So unfortunately, there's no way that we can look back in time from where we are. We can only look at other places as they existed backwards in time. Bukas, for new college students, would you recommend studying astronomy or astrophysics or rocket science? Are there good careers in astronomy? Ooh, this is a sore question. This is a tough question because I don't like giving this answer, but I feel like this is an honest answer. There are not a lot of jobs in astronomy and astrophysics, and there is an enormous cost for you to get a degree in astronomy. You're looking at getting your bachelor's degree in astronomy, and then you're getting your master's degree in astronomy, and then you're getting your PhD. So you're looking at 4 + 2 + 3 years, 7, 9. You're going to look at 9 years of study to get your PhD in astronomy. And often you'll do several years after that as a postdoc until eventually you can be considered a career astronomer. For every position in astronomy, there are dozens, if not hundreds, of applicants who are trying to get that same job. So if you see a job comes up in astronomy, you're going to apply, but also there's another 100 to 200 people who are also applying for that job. And often that leads to people getting frustrated and giving up on getting a career in astronomy and astrophysics and going and getting a job in computers, finance, things like that. Like if you love astronomy, then you have to decide, is that what you want to do as your job? Because there's lots of ways that you can do astronomy. You can do citizen science. You can participate in projects. You can get a telescope. You can even learn the equivalent of a degree through your own study, or learn the degree but not necessarily try to apply it. But if you are going to try to turn this into a career, it's a long, hard road. There aren't a lot of jobs. The competition is fierce and it's poorly paid. Like, I know I'm not making it sound very good. Now, rocket science is a different story. In that case, there actually is a fairly big demand for engineers and physicists working at companies like SpaceX, Blue Origin, NASA, of course, the European Space Agency. There's a lot of jobs in rocket science if you want to go and learn to become an aerospace engineer, as well as aircraft companies, etc. So the recommendation that I always make to people is, if you want to go into, say, astronomy, also consider going into computer science. And so if the whole astronomy thing doesn't work out, and astronomy is mostly about computers these days. You're using computers to crunch the data that you're getting. You're digging through giant, vast databases. Like, having a lot of skill in computers is an absolute necessity for being an astronomer these days. And then if the whole astronomy thing doesn't work out, you can always just take a backup gig as a computer programmer and make $500,000 a year. That's my recommendation is go into computers, but also take some astronomy courses. And if you enjoy it, and then just know that if you're going to try and turn it into a career, it's a very competitive field. Pat W. If our technology today was able to get close enough to a black hole, or as close as possible, what type of things would we be able to discover that we can't, being so far away? Well, it's just like everything. Like, think about how amazing it is to send a spacecraft into orbit around Saturn. and we're able to see the rings and the tiny little moons that are shepherding the rings and the storms inside the surface of Saturn. And it would be incredible. And so if we could get a spacecraft safely close to a black hole, it would be a boon to science that would just be hard to describe. Because, from this distance with black holes, all we really get is their existence, that we can detect, like them gravitationally interacting with some other object as they orbit around each other. Or maybe we can detect quasars, we can detect jets of material as they're feeding. But if you could get really close, you could see the accretion disk around the black hole. You could see the photon ring. You could detect how the light is distorted around the black hole. You could watch as material falls into the black hole and gives little burps of radiation as it dies. It would be incredible. Yeah, if you asked any astrophysicist, would you like a spacecraft orbiting around a black hole sending us data, they would say, yes, please, that would be amazing. But of course, the closest black hole is thousands of light years away. It would take us millions of years to send a spacecraft there. So unfortunately, until we develop a new, faster way to travel, we're going to have to look at them with telescopes from here on Earth. All right. Those were all the questions that we had this week. Thank you, everyone, for asking them. And thank you to everyone for joining me during the live show. It was super fun. Now, remember, this is the last episode as we go on to our hiatus. So we will be back in September with more shows. But there will be other stuff coming out on the YouTube channel over the summer. But I hope you all have an amazing summer. Rest, relax, enjoy yourselves, and I will see you in September. If you want a single comprehensive resource for space news, you want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights, and links so that you can find out more. Go to universetoday.com/newsletter to sign up. And it's totally free. And did you know that all of my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. And I'll put a link in the show notes. Thanks to all the moderators, and a special thanks, as always, to Chad Weber, Nancy Graziano, and Anton Posnikov.